So they want us to solve an ugly looking problem here. So we have a trig function, we have a quotient rule. This is good practice. Let's take the derivative of both sides like this. Let's see what we can do. What's the derivative of tangent? That's secant squared. I'll put a link in the description for how to prove to yourself that that's true. And that's the outside part. What's the inside part for the chain rule? Requires us to multiply by the derivative, which is 1 minus dy dx. And the goal is to find dy dx. So there's a dy dx right there, equals. Then this one looks like it's going to be a quotient rule, u prime v minus v prime u over v squared. I'll write that rule right there for us. U prime would be the numerator prime, so that's dy dx. There's a second dy dx right there, okay, times v, which is 1 plus x squared, minus v prime, that's just going to be 2x, times y. That's all going to be divided by 1 plus x squared squared. It doesn't look like it's going to be easy to isolate any of this, so I think we'll expand out this group here first. So I'll write it as secant squared x minus y minus dy dx secant squared x minus y. Yes, I think we'll do that. And that's going to equal this crowd. Maybe I'll just select it like that. That's better than rewriting it in this particular moment. What do you say? Am I okay with that? Let's bring it over here. Come on. Like so. I'll even make that parenthesis bigger on that side, so it's all good. One more try, and then I'll write it out for you instead. Oh my gosh. Okay, fine. Equals. One last try? Let's do one more try. Equals. Yay, that's about it. Equals this stuff. Then what do we want to do? Well, we're going to need to expand and isolate and rearrange and all that stuff, right? So to get the dy dx, we're going to have to bring this up, this 1 plus x squared. When we do that, that's going to multiply up onto this. How do we isolate this? I think we need to bring the dy dx's over. So we'll add this guy, and we'll get secant squared x minus y equals dy dx 1 plus x squared minus 2xy over the 1 plus x squared squared plus dy dx secant squared x minus y. Now, if I multiply each side, top and bottom, by 1 plus x squared squared, double up squareds, we'll at least have a common denominator, won't we? So I think we can say secant squared x minus y equals, let's try this lot. I want to rewrite the whole thing. So we'll have dy dx (1 plus x squared) minus 2xy plus dy dx secant squared x minus y times 1 plus x squared squared, and all of this is over 1 plus x squared squared. So we'll multiply that up to here and remove anything that I can. So we'll say secant squared x minus y times 1 plus x squared squared equals dy dx 1 plus x squared plus dy dx secant squared x minus y, and that's times 1 plus x squared squared and minus 2xy out there on the end. So we can factor dy dx 1 plus x squared plus 1 plus x squared squared secant squared x minus y minus 2xy. What are the odds this is going to be right? So let's add this to the other side, and then we'll divide by this amount. So I should get dy dx equals 2xy plus what was already over here, secant squared x minus y times 1 plus x squared squared. All of this should be divided by that, which is 1 plus x squared. I'll take the parenthesis out. 1 plus x squared plus 1 plus x squared squared secant squared x minus y. Is that the answer? Just double checking my math here. That is the correct answer. This is how you find implicit derivatives. You do them individually. Here's the original tangent, right? Do them individually. Make sure you apply the trig rules or whatever rules on the outside function, and then multiply by the derivative of the inside function for a chain rule, and then do a bunch of algebra and end up hating life. See you in the next video.